Welcome to a general Python refresher for interviews. This is for you if you've already know and used Python before, but you just don't do it every day, and therefore you've gotten rusty, you've forgotten a few concepts, you've got an interview coming up, and you need to get back up to speed again. And this is why I made this for myself as well. This is good if you're a junior dev or cloud engineer or a DevOps engineer. It seems there's always a coding interview these days, and usually it's Python. Again, even if you don't use it every day, for whatever reason, it's what everybody seems to want right now. It's kind of crazy. There are no data science or machine learning specifics in this particular refresher. It's pretty neutral in that sense. I got a pro tip for you as well before we dive into this is I recommend that you can learn and practice as well at exorcism.org. It's a great site. I have no affiliation to it. It's mostly completely free. I haven't paid anything for it. You can pay to unlock extra features. I love the site. I think it's great. I always go back there to refresh. But from now on, I'm also going to use this video myself to refresh myself and keep up to date with the Python concepts. Let's get straight into this. So just at the beginning, I've just got some instruction here just for my own use. Maybe you do things slightly differently, but this is how to install a virtual environment. So for me, I'm using Linux and I prefer to use Venv. You may prefer to use Conda or something else. If that's the case, then just ignore this and move on. But here I've just got a reminder that this is how I'm going to install a virtual environment and activate it, and this is how I'm going to install using pip, and also any additional requirements. If I want to put all the libraries in one single file, I can stick them all in requirements.txt and do it that way. And finally, at the end, I want to deactivate. So that's just something about virtual environments, a reminder for me. This is a reminder of how to assign a variable. Believe it or not, sometimes you can forget even these simple things. That it's convention to use snake case, so that's lowercase lettering and an underscore in between. And you really want to do this in an interview. Don't go ignoring conventions like this. It's going to make you look like an amateur who is not really using Python at all. So obey conventions. Another convention is to use screaming case convention. That's like uppercase with words separated by underscores. This denotes a constant, which is basically a way of the author saying to the reader and to the user, you should not be changing this variable. Like you can, but you shouldn't be changing it. Okay, so Python won't interpret this any different. It's simply a message to the user. This is how to print a variable. You can just say print the variable like that, or if you want to precede it with some custom string, then this is how you would do it. You would enclose it in quotes. Just another word to say that you can use single or double quotes in Python. It doesn't matter. However, there does appear to be a convention of moving from single to double. Now, me personally, I prefer single because I don't have to press shift every time I want to use quotes. I can just simply press the same key without shift. But there is kind of moving convention towards double. Just something to say. Doesn't really matter. I'm going to continue using single. And your workplace may have a convention, which of course you should also fall in line with. But for now, I'm going to use single. Here is a typical function. You can forget how to do a function sometimes. Def to define it, name of the function, and then after any parameters that you're going to pass. In this case, a single parameter called figure. And then typically you will be returning some value. And in this case, it's simply return 2 multiplied by the figure because this is a multiply function. Now, just something to bear in mind. If you're not passing parameters, if you're not returning anything as a result of that parameter, you're not manipulating it, you don't need this final return statement. Now, I forgot that actually in an interview. It's very rare to not actually do anything with a parameter, to pass a parameter and return it in some form. And I actually forgot that if nothing is going to be returned, you don't need this final line. Okay, you don't need return. Now, getting onto data structures, here is a list, also known in some other languages as an array, and it's denoted by square brackets. So that's what we have here. And in this case, I've just got 4 different fruits in this array, and it's ordered, and it is mutable. You can swap things out. Now here is another one, another data structure called a tuple. A tuple is denoted by parentheses. Do not call these brackets in programming. It will just confuse people because some people see these as brackets. That's why I call these square brackets. and I just call these parentheses. Do not use the word brackets to talk about these, or you'll cause a lot of confusion. Now, a tuple is like a list, but the difference is that it's immutable. You can't change these things. So a very classic example when you use a tuple is for coordinates. If you've got a point on a map and you're saying that's London or that's New York, it's not going to change, right? So very typical to use these for coordinates. Now look, you can just use a list. You can get away with using a list even in an interview. It doesn't really matter. But why is it better to use a tuple for immutable values? And the reason is because it uses less memory. So that's why you would try to use something more appropriate for the use case. If what you're doing is simple DevOps scripts or very basic Python programs, you're not worried about performance, then it really doesn't matter. You can get away with using a list. But bear in mind, sometimes you should be using a tuple instead. Now here is another data structure denoted by curly braces, and this is called a set. Now this is for unordered elements. The order doesn't matter, and they're also unique, so you wouldn't repeat them. The classic case I like to remember is tags. So tags on a YouTube video, or tags on a blog post or something. So in this case, the video or the post is related to people, social, blogs. It doesn't matter if we mix these up, and we would never repeat them. So that is when you would use a set, that they're unordered but they're unique. Now let's look at some operations that we might do here. Okay, so for example, if you want to grab an element or an item from the list, then you refer to it by index value, and in this case we want index value 1. Now just a reminder how it works: we always start at position 0, 1, 2, 3. They increase like that. So in this case, if you want to print something from position index 1, which is here, then this would return you banana. Now in Python and some other languages, index -1 also denotes the final position, and it goes -1, -2, -3, -4. So if you have, let's say, a long list and you want the final position, you would just say -1, and this would return you pair. This is called slicing. What you can do here is you can say, I want to start at 1 and end at 3. But the important thing is that the stop value, you do not include that. So here, start at 1, end at 3. We would start at banana, we would end at pear. So it would go banana, apple, but not pear. So banana and apple. And if you omit either the start or the stop, so in this case we don't include a stop value, it means that we never stop. It goes right to the end. So here we start at 1 and we don't end, so it should return as banana, apple, and pear. So that's why I said here banana, apple, and pear. Now let's look at some other operations, some methods that we can use. You want to add to the end, you use append, which is literally what that means in the English language. To append is to add something on the end. Then if you want to add cherry to the end, you use append. If you want to insert, then you're talking more about at a specific position. So for example, you want to insert at position 0 cherry, then you would use dot insert. And by the way, these are all going to modify fruit, because fruit is behaving like an object, and dot insert is applied to that object. So it's actually modifying fruit, or modifying the list in place. So here we want to insert position 0 cherry. What it will do is it will move orange, banana, apple, pear. It will shift these over to the right. They will actually change position, and that's what I've said here. It will add cherry to index 0 position and shift everything else to the right. Now let's say that we have another list. We're going to call this more fruits, and that's what I've just done here. Initialize it. There's actually nothing in it, but I could have put some fruits in here. It doesn't matter for our purpose. Now what we can do is we can extend existing list fruit with another list more fruits, and so it will join the new list more fruits to the end of the existing list, which is fruit. And remember, it modifies fruit in place. We don't need a new variable for this. Now if you want to remove an item or an element, same thing, from the list, then you would use remove, dot remove. So for example, you want to remove banana, you would use dot remove banana. If there's multiple of banana in this list, it will remove only the first one. If you want to remove the last one, now pop is very special. It's more than just removing the final element. What it will do is it will remove it, and it will also return the value. So fruit.pop parentheses with nothing inside will remove pair, but this whole thing will actually become the value of pair. So you can not only remove pair, but you can also use it later on in whatever operation you're doing. So you kind of like, it's kind of like using a list like a rudimentary queue. You're removing the last element, and you're also going on to use that last element for something. Now, if you pass a parameter to pop, you can actually remove it from a specified index. So you might use 0 to remove the first element instead. And again, this becomes whatever you're removing. Now, you can't pop a tuple, remember, because this modifies fruit in place. When it removes whatever element, it will actually modify fruit. So you can't pop a tuple. But what you can do is you can convert that tuple to a list. You can pop it and then convert it back to a tuple. So, but tuples, remember, you're using them in the first place because they're immutable. So you shouldn't really be trying to mutate it in this way. But, you may have a reason to want to pop a tuple. Now, .sort will sort a list in place. But if you don't want to modify sort, then what you can do is you can actually use sorted instead on fruit, and then let a variable be equal to that. So this is a sorted copy rather than sorting in place. If you want to count the number of a particular element in a list, you can use .count. This will search the number of oranges in that list above. If you want to get the position of the orange, then you can use .index, and it will return the position. Now, of course, if you got more than one orange, then it will just return the first one that it finds. Now, this is going back to this tuple we had. Remember this? It was a tuple of XYZ coordinates. Now, remember, a list uses square brackets. However, other data structures use different things. Tuple will use parentheses, a set, and also a dictionary. You'll see later will use curly braces. However, when you want the element from a tuple, then you'll actually still use square brackets. A little confusing, but that's just the way it works. You will always use square brackets when trying to grab values from it, grab items or elements. And the same also applies later on. You're going to see even for other things, sets and dictionaries. So in this case, we want the position 1 element from a tuple, which is it's going to be this here. The second position is going to be the y coordinate. Then that will grab us 73 out of here. And yeah, like I said, we use square brackets anyway. Now let me show you another operation that you can use here. I'll just scroll to the top as well. Let's say we have a variable. It could be a list. It could be a string. It really doesn't matter. What you can do is use len, and it will return the length of number of items or elements in that list, or for a string it will return the number of characters. Actually, a string kind of acts like a list. You can perform operations on that. You can grab the index of a string and it will return you whichever character you're referring to. So it's kind of interesting like that. Now I want to show you some other kind of control things. So in this case we've got conditionals, which you'll find in all programming languages. And what you can say is, so let's say my variable is a string, or it could be actually an integer, a whole number. If my variable is equal to 2, then print equals 2. Else if, or otherwise if, my variable is equal to 3, then print 3. Otherwise or else, print neither 2 nor 3. Now, if you don't remember, 2 equal sign is kind of like, if it was 1, we'd be assigning a value to a variable. This is for a condition. It's saying look at the two sides and is equal to, are they equal to each other? Now look, let's say that we're not care about this final case where we print neither 2 nor 3. Let's say that we're only interested in 2 or 3. We don't actually need else if. We can actually just use if. And the reason is that if something is a 3, right, then it's not a 2. They're completely independent events. It can't be that something can be both. So if they're completely independent events, you don't need else. You can just say if. And you'll see a lot of this simplification as you get more experience with using these control structures. But don't have too much of a headache over it. You'll probably get away a lot of the time with just using else if, but think about it. Think about what's happening in the different cases. That would be my advice. And also, if all you're doing is a simple one-liner in each case, that's what I've said here, then you can actually just move this and put it next to the colon. And that's what I've done here. If a variable is 2, then print 2. If the variable is equal to 3, then print 3. As simple as that. Now, what we've got here. So now I want to show you something about Boolean logic in Python, and it's really quite cool. So let's say you've got a function here, and it's a test to see if something is big, and it takes 2 parameters. Is it tall and is it wide? And basically, I'll just tell you now, we want it so that if something is both tall and wide, then basically it's big. So you can see here, the first test is if tall is equal to true and wide is equal to true, then is big is equal to true, and we return is big. We return true. Otherwise we're saying if it doesn't fulfill that test, else is big is equal to false. So return false. Now this can be reduced. So in the second block here is a reduced form, and you can see the difference here is that we're missing this else is big equals to false. And the reason is because if this whole thing up here is fulfilled, you know, that tall is true and wide is true, and therefore we're going to return true, and then therefore is big is true, we're going to return that it's big. If we don't fulfill both of these conditions, tall and wide, then it remains false. So we can just get away with saying this. We don't have to explicitly say else false. We just don't have to say that. And now you can even reduce that even further. What you can do is you can say return tall and wide, because tall if it's true and wide if it's true, then true and true equals true. False and false is false, true and false is false, and false and true is also false. It's only when both tall and wide are true that we are going to return for the whole big function a true value. So this is a way to reduce all of that. Here is another similar example. You can have a function called are equal, and the idea is we're passing it 2 variables, 1 and 2, and are they equal. And what you can do is you can return var1 is equal to var2. Have you noticed there's no if statement here? And the reason is because what will happen is this here will get evaluated, and is equals to says look at the left and look at the right hand side, and if they indeed are equal, return for this whole thing, return a value of true, this whole condition thing here. So that's a really nice way. We don't have to have any if or any conditional in there. So that's pretty cool, and it's something I think that's fairly unique to Python. Now, this is one thing I often forget in terms of arithmetic operators. It's easy to remember plus, minus, multiply, but I often forget division. Now, simple division is just like this, and you end up with obviously even from 2 integers you may often end up with a float, 3.33333 recurring. However, I often forget the other alternatives. So you've got the double slash, which is known as the floor operator, and this will round down. So instead of 3.333, it'll just round it down to 3. And this is the one I always forget, is the modulo operator. It looks like a percent sign. And what this will do is it will return the remainder. So if you do 20 divided by 6, that equals 3, but with 2 left over, because obviously 6 multiplied by 3 is 18, and that leaves 2 remaining. Now this is the other major sort of control thing that you can do in programming languages is looping, and usually mostly we're going to talk about for loop, but I will also mention that there is also a capability of a while loop in Python. So classic one, you know, you would just say for fruit in fruits, print the fruit. Now this is the case where we had before that the fruits was a list, but it could also be a string. We could be looping over characters in a string. The key is that both of them are iterable. Now one of the keys here is that I've said for fruit in fruits, and that word fruit, really it could have been anything. I could have said for thing in fruits or for object in fruits. But the key is that whatever you decide to put there, you then refer to it later in the function. So I've said fruit can be anything as long as you reference it later. And I said that fruits is iterable. We can count over the number of fruits. So it's for definite counted iteration. Now, when you have something that's not definite and you don't count it, then you would use a while loop. And so a classic example is, while a fruit or whatever variable, while it has the value of true, then do this. In this case, it's, keep popping the list. It could be anything though. I've just said keep popping the list, and it could be until eventually the false condition. And you could have this different. You could say while something is less than 3, then keep doing something, and maybe eventually it becomes 3 because of what you're doing, or it could be because of some other event out of your control. As long as it's above 3, keep doing whatever's in the loop. But the moment it goes below a certain value, it could go below 2.6 or 2.5 or whatever, then you want to stop the loop. And that's when you would use a while. So in a while, you're not counting anything. It's indefinite. So let's move on now. We iterated over a list before, but you can actually, if you already know definitely the numbers that you want to count over, like 1 to 10 or something, you can use range. So for number in range 1 to 10. And what you can also do is you can have an optional step here. So this will count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but you can also say comma 2, and it will go 1, 3, 5, 7, 9, like that, for example. But in this case, it's a step of 1, it's implied, and it will just print out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now this is super useful. A lot of other programming languages don't have this. If you want to have access to the index that you're on, when you're iterating over all the fruits in this list, you want to have access not only to the fruit and refer to that, but you want to also refer to the index. You can say for index, fruit, enumerate fruits. And then this will also allow you to do things with the index. In this case, it just prints the index, prints the fruit. So it would say, in this case, it will go 0, apple, 1, banana, 2, cherry. And this is super useful. It's also especially useful. Let's say you've got 2 lists. So you've got 2 different lists of fruits. You've got one that's apple, banana, cherry. You got another one that is, I don't know, orange, passion fruit, mango. But the order is important, and then what you can do is you can refer to another list but using the same index, and that way you're going to get the first fruit in both lists, the second fruit in both lists, the third fruit in both lists. You can print them in pairs, for example. This is often a case when you might use the index in this way. Now here is, I want to show you something called continue, and what this allows you to do is to force the next iteration immediately. So if the fruit is apple, then go advance to the next fruit. Do not continue in this loop. So in this case, if the fruit is apple, it will never print the name apple. It will just go immediately to the next one, and you will only print out banana and cherry. And this is another similar loop, but in this case we've got break. And what it's saying is if the fruit is apple, then just break completely out of this for loop. It's a bit like in Monopoly, do not pass go, right? If the fruit is apple, just break out of this loop and just continue the rest of the program. So it force breaks out of the loop. You don't use this often, but it has its uses. And now we're no longer in for loops, but we're just in a random function. I want to show you here a classic example of when you might use pass. So pass is a null operation, or also called a placeholder, and it's where you intend on replacing or removing it later. So let's say you decide, I've called it a random function, but it could be anything, but you've decided you're making a program, you're coding away, and you need a function to do something. So you just type out the name of the function you've already decided on, but you're going to come back to it later. So you're just going to put the word pass in it, and this way it won't break the program as you're debugging the rest of the program. It won't be flagged as any kind of error or just because you haven't finished the function. So it's very useful, especially for writing incomplete functions. Now moving on to another data structure which is called a dictionary, and in the modern world, key value store is is something you see in NoSQL databases. It's incredibly common, and maybe it was less so in the past, but it's incredibly common today. NoSQL databases, JSON, all that kind of stuff, key value store. So that is what a dictionary is, and we use here curly braces. And if you remember, we used curly braces before for a set, and yeah, actually there's some commonality here, because this is the key, this is the value, they're separated by a colon, and the keys have to be unique and unordered. And that's kind of what should remind you of a set. Remember that we had in a set like tags for a YouTube video, they were all unique, we didn't repeat them, and they were also unordered. It didn't matter what order that the tags were in. And it's the same with keys, with keys in a key value store like a dictionary. It doesn't matter if name Alice comes at the bottom. It really just doesn't matter. And also, we won't repeat name more than once. It's unique. We won't repeat age or city more than once. So it has a lot of similarities with a set. Now let's look at here how we can construct a dictionary. This is one way to construct it, and the easiest way. However, there are other ways that you may need to use. Now, this is a constructor called a dict, and it can be used in three different ways. One is you can have a list, so that is the square bracket there, and inside that list you can have a number of key value tuples. So in this case, name horse, land animal, true. So that's one way. Another way is, instead of having a list of tuples, you can just instead pass as the parameters key value pairs. Name equals horse, land animal equals true. So key value pairs, which are arguments for that are being passed to this, basically this function dict. Another way that you can do it is, this is useful when you don't know what values are going to be. So you don't know if it's going to be horse and true. You just know you're going to have a name and a land animal. You know what keys you're going to use. So maybe you're initially populating a database with no values but just the keys. So you would say dict.from keys, and in here you would then put in name, land animal, and as a list, and then here you would put a default value. So in this case, it's going to be default for all of them. This is just a suggestion. It could be blank, it could be 0, it could be whatever you want. Now here is the key. I already alluded to this already, but for keys you can only have immutable data structures. So you cannot have mutable structures. So that means you cannot have lists, you cannot have sets, which are also which are mutable, they're changeable, and you cannot have a dict as a key for a dict as well. So you can only have immutable data structures. Immutable means that they're therefore hashable. So numbers, strings, tuples. Now, you may need to reread that later just to sort of get that, or you may just want to memorize the fact that for keys you can use numbers and strings and tuples, but you definitely cannot use lists, sets, and dicts. You may want to digest that later. Now, how do we access values in a dictionary? Oh, and by the way, you'll get used to just seeing here strings most of the time. You're going to have a string as a key. So that's the easiest way to remember it. Typically, in a NoSQL database or a key value store, your key will almost always be a word, or something, which is basically a string. So don't worry about that too much. Now, how do you access the value? How do you get values if you know the key? Now, what you will do is, remember before we talked about using a square bracket to access an element of a tuple? Then it's the same thing. Anytime you need to get a value, you always use a square bracket. It doesn't matter if it's a tuple or something else like a set or a dictionary, then you use square brackets. So in this case, we want to grab the value for the key that contains string name. Then we use this, and you can see we've done that for age and for city. Don't worry about the here, although here we are using these curly braces. Don't get confused. This is because we're using F strings. Okay, so down here I've got a better example. Let's move down here, and you can see here. You can see here that we're making reference to a value. We're saying that person square bracket key, person square bracket key, email or age. Now this is a bit different because we're actually assigning it with something new, but I just wanted to demonstrate that to get a value you do dictionary and square bracket. So dictionary square bracket. This here, oops, this curly braces is just because it's an F string. Now let's look at some operations that you can do. Now to get a value, you can do dictionary.get, and it will look up on this key name and it will return the value. Now this is quite elegant, you should say. If it doesn't find it, it'll return a string or whatever you want to put in there. So this is quite common, not found. This is similar, but what it will do is if it doesn't find a value for name, it doesn't find that key name, it won't report back not found. It will actually populate a default value that you want. So in this case, if it doesn't find name, it will actually say, okay, I'm going to create a key value pair called name John. So that's what it will do. It will actually insert a key and a value. And you can pop a dictionary just like you could pop a list, but what this will do is it will obviously take out the entire pair. It won't just remove the value, remove the entire key value pair, and then the entire value of this statement here will be just the value, okay? But it will remove the entire KV pair, something to bear in mind. If you just want to look at a list of all the keys and all the values, then you would use .keys, .values, and if you want an entire object of key value pairs, then you will use .items. So this is useful for when we want to use for loops, okay, just to let you know, because these are iterable. Now if you want to add more key value pairs, what you can do is you can use .update and it will insert these. Now there is an order of insertion here. It's preserved first in, first out. When, for example, let's say you want to print this entire person dictionary, then name and age will and city, it will appear in that order. So this is called FIFO. There is an order to this. Even though the order doesn't matter when you want to retrieve a value from a specific key, it still will respect the fact that you started with name, you ended with age, you ended with city, and maybe you added again another city, but it will still preserve that order. So when you print them out, it will go name, age, city, and that's known as FIFO. It can be useful. You can actually reverse the order if order is important to you, but for most people with a dictionary, order is absolutely unimportant. Okay. Now, moving on to control, I mentioned before that you could iterate over person.values, or you've also got .keys or .items or whatever. So for example, for value in person.values, print the value. And if we do that, we'll end up with all those values like John, 36, which is making up his age, New York, etc. That's what it will do. Now, here's how you can, we weren't looping over the dictionary, we're only looping over a bunch of values here, but here's how you can also, let's say we have a dictionary, in this case I've just said it's blank, but obviously it would have something in there. I've just done this to avoid having all these red squiggly line errors all over my code. But what you can do here is, there's a couple of ways you can loop over a dictionary. So one way is to say, for the keys in the dictionary, then you can then print the keys and the values by saying print the key and print myDict and square bracket on the key, which will give the values. Now another way to loop over and get the keys and values from a dictionary is to say, for key values in myDict.items, remember items is key value pairs, then you can say print key values. It knows that the key is the first thing in the items and the value is the second. So these are both equivalent, both are perfectly valid, and one is neither better than the other. You can really use either. Now let's say as well that you want to add, if you want to add a new key value pair, then this is typically how you would do it. You would say dictionary square brackets the key equals whatever value. Now we did see another method earlier which was set default, but if all you want to do is just straight up do it like this, then this is how you would do it. Now I gave this example here because in our dictionary we did not have email there, but if you look, using the same format you can also use it to update. So we already had age, and if there's already an age there, which we did have, this will update the value to be clear, this overwrites the value, so it only shows the new one. The old one is long gone, forgotten, can never ever refer to it again. So it's the same format. So basically it does the same thing. It will add a new pair if it doesn't exist already, or if the key is already there, and obviously there should be a value probably there, then it will assign it with this value. If you want to remove a KV pair entirely, you can use del. If you want to print the entire dictionary, you can just say print and just put the name of the dictionary. Now finally, in this tutorial, this refresher, I just want to show some examples of using a dictionary. So here is an example. You've got a function called create an inventory, and what this is going to do is count items in a list. Okay, and I've actually got here a doc string which explains it, which is good practice. It tells people the purpose of the function. It also says here the parameter and what it's called and what the type is. It's a type list and a description of that type. It's a list of items we want to create the inventory from. So this is the parameter, and we're going to return from this a dictionary, which is an inventory having counted all those items. So what I've done here is initialize the inventory with nothing in it to start with. It's a dictionary, okay? And you might say, well, that could actually be a set because I'm using curly braces, but in this case it's a dictionary. And what we're saying is, for the list, for every element in that list, if that element is in the inventory, then take the dictionary and add the key, and as a value increment by 1. So it won't be, because we're just starting with the first element in this list of items. So the first time it will just be like this. It will simply add it with a value of 1, okay? And then we run it again. So let's say this is an orange, then we've got our first orange. And then let's say the next element is an apple, right? Then if the apple is already in the inventory, which we know it isn't, it's the first apple that we're counting, again, put an apple in the inventory and give it a value of 1. So we've done orange, we've done apple, and both times they weren't found, and it went here and it said, okay, add an apple and add an orange in our inventory and give it a value of 1. Now let's say in the list we've got apple and orange again. So we've got apple, orange. Then in this case it will come in here and it will say, if the apple is in the inventory, which yes it is, then okay, just increment it by 1. So the apple or the orange will become 2. And again, the same for the other fruit. So the first time it sees apple, orange, or whatever fruit it is, it will assign it a value of 1. Thereafter, it will increment by 1. And finally, when it's gone through the entire list of items, it will return as a dictionary key value pairs of all our fruits. It could be apple 5, it could be orange 28, cherries 3, something like that. So I wanted to give you just an example of a nice little inventory function that will take a list of items and create you a dictionary of key value pairs having counted all those items. And you'll see this in many programs. Very similar thing. Now, remember that intrinsically a dictionary does not have order. Although there is this whole first in, first out thing, intrinsically it doesn't really have order. It doesn't matter where the key value pairs are in terms of retrieving values fast, as if it were like a database. So you can't sort a dictionary. However, what you can do is you can sort a view. So if you use mydict.items, which remember produces the key value pairs, and I think it produces them, there you go, it says a set-like object. Okay, it's not a list, but it's actually a set-like object. Then you can sort that, and then from there you can create a dictionary having sorted them. And that will create you a kind of sorted dictionary. So yeah, you can sort a view, but you can't directly sort a dictionary. And this is how you would do it. Now I want to show you finally just some operation if you've got two dictionaries. So I've said here, I've called them first dictionary created and the second dictionary created. Now here they're just blank, and I just did that to avoid errors in my code. So you can ignore that, but they could easily just have things in them. And what you do is, you could use an operation on the second dictionary object, which is called update, and what this will do is it will update the second one with the key values from the first one. Now if the second dictionary already has keys that appear in this first one, then it will, because we're updating the second dictionary, remember, if there are keys in here that are already in here, it will overwrite them, and this will take precedence, this will dominate, because this is being acted on with this new dictionary, if you like. This is very similar. You can use pipe equals, and this is all. And if you use just pipe alone, this is also similar, but it will create a new dictionary. It will not update second dict, so you have to assign it as a new variable, like third dictionary. So I know that was a long video, 40 minutes, but this should hopefully be all that you need to be refreshed to the level that you need to interview and show that you can use Python. I would also recommend, though, go to Exercism, check it out, and do some learning and practicing on there. Do a few of the exercises. Then you'll really develop that muscle memory. You don't get muscle memory from following a video, but by actually using it. But this should refresh you more than enough to even tackle those exercises. So good luck in your interview. Let me know how it went, and check out the rest of the channel for similar videos. I wish you all the success, and see you again soon. Bye bye.